Hello out there, welcome to this tutorial on binomial expansion. In this video, we'll be looking at the binomial theorem. This is lesson 1 of the topic binomial theorem. Check the description section of this video to get the link to the first video on binomial expansion where we treated Pascal's triangle. So we start with the statement of the theorem. X plus y all to the power of n is equal to n combination 0. Then the first term in the expansion is going to carry the highest power, which is x raised to power n, while the second term y will be y raised to power 0. Since any number raised to power 0 will give us a 1, so we need to save space there, so we leave out that one. Then plus the next term is going to be n combination 1. If you look at it, the subscript is increasing. Then the power of x, which is the first term in the bracket, the power will be decreasing, so it is going to be x raised to power n minus 1. Then y will now gain power 1, which is the subscript here, so we have it as y raised to power 1. Either you take it as this subscript or this 1 that is subtracting n. So in the next term, we are going to have it as n combination 2, then x raised to power n minus the 2, x raised to power n minus this 2, then we are going to have it as y raised to power 2. Then we continue up till n combination r. So what is it going to be? X raised to power n minus r, then y raised to power r. Then we continue to add until we get to n combination n. Then at that point, the power of x is going to be 0, because it's going to be n minus n, which is 0, and x raised to power 0 will give us 1. For the purpose of space, we leave out that one, and y will be raised to power n, which is the subscript here. This is the statement of the binomial theorem. Then we'll say where n combination r is equal to n factorial over r factorial, then n minus r factorial. This can also be equal to, by expansion, we have n into n minus 1 into n minus 2 up till n minus r plus 1, then over r factorial. If we expand this, this is partly what you are going to have. And note that n combination r can be written as still n combination r, where n and r here are subscript, or as column vector here as n r. So this is the other way we can write the n combination r. If it is 5 combination 3, now to be 5r here. And also note that n factorial is equal to n times n minus 1 times n minus 2 times n minus 3 up till times 4 times 3 times 2 times 1. So this has been taken care of in permutation and combination. Check our channel also for the videos. Now this is the binomial theorem we'll be using to solve binomial expansion in this video. So we start with the first problem. Problem 1, expand 1 plus 3x all to the power of 5. In our solution, we have 1 plus 3x all to the power of 5. Remember, the first term is 5 combination 0, since n is 5 here. So 5 combination 0, then 1 raised to power 5, and 3x is not coming in here because it is going to take 3x all raised to power 0, which will still give us 1. So for the purpose of space, we are leaving that one out. It is not a crime if it is left out. Even 5 combination 0 can be left out. So take note of that, depending on the material you are using. You may ignore this, or you may include 3x raised to power 0. Then we go to the next term. That's going to give us 5 combination 1, and multiply by 1 raised to power 4. Remember, 5 minus 1 will give us 4. That will be the power of the first term. Then the subscript here will now be the power of 3x. So we have it as 3x all to the power of 1. Then we go to the next term, plus 5 combination 2. Remember, this is 0, 1, 2. And the power of 1 here is going to be 3. So 5 minus 2 is 3. So we have 1 raised to power 3. And the power of 3x here will be 2, the subscript. So we have it as 3x squared. Then we go to the next term. That's going to give us 5 combination 3. Remember, it is going to be times 1 raised to power 2. Then we bring in the 3x, which is going to have power 3. So we have it 3x to the power of 3. Then the next term is going to be 5 combination 4. So we have it as 5 combination 4 multiplied by 1 raised to power 1. You still remember 5 minus 4 is 1. Then multiply by 3x raised to power 4. Then the last term now is going to be 5 combination 5. You know, 5 minus 5 gives 0. So 1 raised to power 0 will still give us 1. So we forget about that. Then we now bring in 3x to the power of this 5, which is subscript. That is the end. The power, which is 5 plus 1, will give us 6, meaning we're going to have 6 terms in the expansion. So the number of terms is always n plus 1, which is where n is the power. So we count now 1, 2, 3, 4, 5, 6. So the power here is 5 plus 1, 6. So we have 6 terms. We now simplify the coefficient. So we have it as going to be equal to 5 combination 0 is 1. Then 1 raised to power 5 will still give us 1. Then plus 5 combination 1 is 5. You can use your calculator, or you can work it out by the side. So the option is yours. But at any point, just press your calculator, 5 combination 1, and you are there. So this is 1 raised to power 4 will still give us 1. 3x raised to power 1 will give us 3x. So we are done simplifying this. Then we go to 5 combination 2. 5 combination 2 will give us 10. So we have it as 10. And 1 raised to power 3 will still give us 1. 3x squared. You are squaring everything inside the bracket. And that's going to give us 9x squared. Since 3 squared is 9, we have it as 9x squared. Then we go to the next term. That's plus 5 combination 3 again is 10. So we have 10 times 1. Then 3 raised to power 3 gives 27x raised to power 3. So we have it as 27x raised to power 3. We are done with this term. For the other term, we have it as 5 combination 4 gives 5. Then 1 raised to power 1 gives 1. Then 3x raised to power 4. 3 raised to power 4 is 81. So we have it as 81x raised to power 4. And the last term, 5 combination 5 is 1. So we have it as plus 1. Then 3x all raised to power 5. 3 raised to power 5 is 243. Then x raised to power 5. So we then simplify to get the final coefficient. 1 times 1 gives 1. 5 times 3 gives 15. Then we have it as 15x. This is going to give us 90x squared. So we have it as plus 90x squared. Then this is 270. Because 27 times 10 gives 270. So we have it as plus 270x3. Then here we are going to have it as 405x raised to power 4. Then plus 243x5. So with this, we have successfully expanded the problem represented in problem 1. Then we go to problem 2. For problem 2, we are to expand and simplify 2x minus y all to the power of 4. So what we do, the coefficient of x in the first term of the bracket is 2. And here we have this one as -1 as coefficient. So you have to be very careful if you are dealing with negative value inside the binomial expansion. So we'll take a look at this. In our solution, we have 2x minus y all to the power of 4. The power here is 4. And remember, we are going to have 5 terms. And starting from 4 combination 0, then at the first term, which is 2x, we start with the highest power of 4. So we have 2x to the power of 4. Remember, this minus y is going to be raised to power 0, which will still give us a 1. So we don't need to represent it here. Then the next term will be plus 4 combination 1. We are going to have it as 2x raised to power 3. 4 minus 1, 3. So we have 2x raised to power 3. Then the second term in the bracket, which is negative y, we carry power 1. So we have it as negative y raised to power 1. We are done with that term. Then the next term is going to be 4 combination 2. Since this is 0, 1, the next term is 4 combination 2. Remember, 2x to the power of 2. 4 minus 2 is 2. Then negative y raised to power 2, which is this subscript. Then we have gotten 1, 2, 3 terms, remaining 2. So the fourth term is going to be 4 combination 3. Then we have 2x raised to power 1, where negative y will be raised to power 3. And the last term, we are having it as 4 combination 4. This is already gone because it's going to be 2x raised to power 0, which will give us 1. So we can easily leave that one out. Then negative y raised to power 4. So we are done. 1, 2, 3, 4, 5. We have gotten our 5 terms. Now what we do is to simplify the coefficient coming from the combination. So we have it as going to be 4 combination 0 is going to be 1, and 2x all to the power of 4. 2 raised to power 4 is 16. Then we now have x raised to power 4. So we have it as 16x raised to power 4. 4 combination 1 is 4. So we have it as plus 4. 2 raised to power 3 is 8. Then x raised to power 3. So we have it as times 8x raised to power 3. Negative y raised to power 1. Since the index here is odd, so it's still going to be maintaining the negative. So we have it as minus y, then plus 4 combination 2 is 6. Then 2x to the power of 2. 2 squared is 4, then 2 squared. So we are going to have it as 4x squared. Then since the power of negative y is even, so the negative will disappear, we'll be left with y squared. Then that's going to be plus 4 combination 3 gives 4. Then 2x all to the power of 1 will just give us the 2x back, minus y. all to the power of 3. It means the minus is going to be maintained since the index here is odd. So we have it as negative y to the power of 3, then plus 1. Since 4 combination 4 gives 1, then negative y to the power of 4, that's going to give us positive. So we have it as y raised to the power 4. So finally, we simplify out. 1 times 16 x raised to the power 4 gives 16x raised to the power 4. 4 times 8 gives 32. 32 times negative 1 here will give us negative 32x raised to the power 3, then y. Remember this minus here multiplied by this plus will give us negative. So that's why that term has negative coefficient. Then for here, we're going to have 6 times 4, which is 24. So we have plus 24x squared, then y squared. For your information, at every term, the powers or the indices add up to give us 4. If you are working with power 5, for instance, again, the individual index, when added, we always give it a 5 also, 6, 7, and so on. So like I can see, 2 plus 2 will give us 4. This is 3 plus 1, 4. So we go to the next term. 4 times 2 gives 8. And multiply by negative 1 will give us negative 8. So we have it as minus 8x y raised to power 3. Then plus y raised to power 4. We are done expanding and simplifying the problem represented in problem 2. Then we go to problem 3. For problem 3, expand and simplify x squared minus x all to the power of 5. Remember, this is x squared, this is negative x. So in our solution, remember we are starting with 5 combination 0. Since the index is 5, so it's 5 combination 0. What's our first term in the bracket? X squared. So we have it as x squared to the power of 5. Remember, 5 minus 0 is 5. Then negative x raised to the power 0 will give us 1. So we ignore that one. We go to the next term. That's going to be plus 5 combination 1. Then what is it going to be? X squared raised to the power 4. X squared raised to the power 4. Then the negative x will come in to take the power 1 here. So we have negative x raised to the power 1. We are done with that term. Then plus 5 combination 2. We are going to have it as x squared raised to the power 3. Then we have negative x all squared. Then the next term is going to be 5 combination 3. Then we have it as x squared raised to the power 2. Then this one, which is negative x, will be raised to the power 3. Then we go for the next term, which is 5 combination 4. This one is going to be x squared raised to the power 1. Then negative x raised to the power 4. And the final term, which is 5 combination 5. We don't need this. This is gone because x squared raised to the power 0 will give us 1. Then we are now going for negative x raised to the power 5. Then we now simplify the coefficient. 5 combination 0 is 1. Then x squared all raised to the power 5. This is indices. So what we do, we multiply out the indices. So that's going to give us x raised to the power 10. Then plus 5 combination 1 is 5. Then 2 times 4 gives 8. So we have x raised to the power 8. Then this is going to be negative x. Remember, if the index is odd, the negative sign will be maintained. If it is even, the negative sign will be truncated. So we go to 5 combination 2. So that's going to give us a 10. Then x raised to power 6. Then this is going to give us x squared, since the negative is going away with the even index. Now in the next term, now we are going to have 5 combination 3, which is a 10. Then x raised to power 4. This is going to be negative x cube. So we are done there. 5 combination 4 is 5. So we have it as plus 5x squared. Then x raised to power 4, because the index is even. So the next term, 5 combination 5 is 1. Then this is going to give us negative x raised to power 5. So multiplying out, finally, we have this as x raised to power 10. So negative times positive here gives negative. So we have it as negative 5. Then x raised to power 8 times x raised to power 1. Still remember your indices. It's going to give us x raised to power 9. Then plus 10. The coefficient there is going to be 10. X raised to power 6 times x raised to power 2. You just add the indices to give you x raised to power 8. Then minus, because minus times plus will give us a minus 10 x raised to power 7. 4 plus 3 gives 7. Then the next one is going to be positive, so that's going to be plus 5 x raised to power 6. 2 plus 4 gives 6. Then finally minus x raised to power 5. So we have expanded and simplified the binomial expansion represented in problem 3. So we go to problem 4. For problem 4, obtain and simplify all the terms in the expansion of x squared plus 3 all to the power of 6. In our solution, we have x squared plus 3 all to the power of 6. The first term is going to be 6 combination 0. Then this is x squared raised to power 6. 3 raised to power 0 is going to give us 1. Then the next term is going to be plus 6 combination 1. X squared raised to power 5. Then 3 raised to power 1. Remember, 3 is the second term in the bracket. The first term is x squared. We go to the next term, which is 6 combination 2. 6 combination 2, then multiply by x squared raised to power 4. Then 3 squared. Remember, the subscript goes for the power of the second term, which is 3. And the difference between the superscript and the subscript gives the power of the first term in the bracket. Then we go, this is going to be 6 combination 3. Then x squared raised to power 3. 3 raised to power 3. Plus 6 combination 4. X squared raised to power 2. Then 3 raised to power 4. The next one is 6 combination 5. X squared raised to power 1. 3 to power 5. Then plus 6 combination 6. This is gone, so we have 3 raised to power 6. We simplify. That is going to give us a 6 combination 0 is 1. Then this is going to be x raised to power 12. 2 times 6, 12. Then this is going to give us 6 x raised to power 10. Then times 3. Here is going to give us 15. That is going to be plus 15 x raised to power 6, 9. This is going to give us again 20. 20x raised to power 6, then times 27, since 3 raised to power 3 is 27. This is going to give us plus 15x raised to power 4, then 81, then plus 6 combination 5, which will give us a 6x squared, then times 243, since 3 raised to power 5 gives 243, then plus 1, which is 6 combination 6, then 3 raised to power 6 gives 729. Final simplification, we have it as x raised to power 12 plus 18x raised to power 10 plus 135x raised to power 6 plus 540. This is this x raised to power 6. Here again we have it as 1215, then x raised to power 4 plus 1458 x raised to power 2, then finally we have it as plus 729. This is the end of solution to this problem 4, and this is where we are ending this tutorial for lesson 1. Remember to check the description section of this video to get the link to the other videos on binomial expansion, both for Pascal's triangle and the binomial theorem. I hope you enjoyed this video. Please watch, like, and share. And if you have any reservation, the comment section is open. Until we come your way again, goodbye.